Guys, in today's video I will give simple tricks to calculate number of isomers. You have to simply learn the trick and calculate isomers without drawing a structure of given organic compound. If you like this video, don't forget to subscribe my channel. Now let's start. So in the topic isomerism, the term isomerism was coined by Berzelius coined the term isomerism. So we have the simple rule to calculate the number of isomers. Here this column represent number of carbon atom and this column represent isomers, number of isomers. So if there is one number of carbon atom, then there will be one isomer present, and if there is two number of carbon atom, then also one isomer is present, and if there is three number of the carbon atom, two isomers are present, and if four number of the carbon atom, then four isomers are present, and if five number of the carbon atom, eight isomers are present. So you have to simply learn this column. This column represents serial number 1, 2, 3, 4, 5. So you have to remember this column by simple mnemonics. 11,248. So 1, 1, 2, 4, 8. You have to simply remember this column. So after this you have to know the functional isomerism, in which it differ by the functional group. First of all, alcohol and ether. Alcohol represented by the OH functional group, and ether O, ROR. R means alkyl group, O functional group, and R also represents alkyl group. So second functional isomerism belongs to aldehyde and ketone. Aldehyde represents RCHO, where R is alkyl group and CHO is functional group, and in ketone ROR. R represents alkyl group, O functional group, and this is RC double bond O, R. It represents ketone. Now in third, first degree amine, second degree amine, and 3 degree amine are functional isomers to each other. RNH2 represents first degree amine, and RNHR, this represents second degree amine, and RNRR, this represents 3 degree amine, where R is the alkyl group and NH2 is the functional group. Here two alkyl groups are present. It may be similar or different, and H, and here three alkyl groups. These may be same or different, and N. This represents functional group. So fourth functional isomerism belongs to carboxylic acid and ester. Carboxylic acid RCOOH, where COOH represents functional group, and RCOOR dash, and this represents functional group. So in this page you have to remember only this isomers rule, 11,248, and you have to remember these functional isomers. So now fifth isomer belongs to cyanide and isocyanide. Cyanide and isocyanide. Cyanide. Cyanide means CN group, where CN is functional group and NC represents functional group of isocyanide. Now sixth functional isomer and last functional isomer in organic compound belongs to nitro and nitrite group. Nitrite. NO2 represents functional group of nitro group, and nitrite group O double bond NO. ONO represents functional group of nitrite. So you have to remember these functional isomers. So let's go to the trick. First of all, one question. Find the number of isomers of C5H12O. You have to find the number of isomers of this molecular formula. Now you have to write this in the alcoholic form. In alcoholic form, first of all, CH3, CH2, 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 1, 2, 3, 4, 5 carbon and OH. 12 hydrogen are present. Calculate. Number it 3, 5, 7, 9, 10, 11 and this 12. So we have write down the alcoholic form of this given molecular formula. So here count the number of carbon atom. Number of carbon atom equal 5. So we have to remember that rule 11,248. If number of carbon atom is 5, 1, 2, 3, 4, 5, number of carbon atom is 5, then isomers equal 8. Isomers equal 8. We have to remember this rule. And so now alcoholic isomers of this molecular formula is 8. Then we have to write in the ether form, because alcohol and ether are functional isomer. So we have to write down it in ether form. So 1 carbon, 2 carbon, 3 carbon and O 4 carbon, 5 carbon. We have to simply write down this carbon atom in which hydrogen is filled here. Now here is number of carbon atom. Number of carbon atom. You have to choose the longer group. Longer group. Here 2 groups are present and here 3 groups are present. So you have to choose longer group. 1, 2, 3 carbon atom. 3 carbon atom. So isomers equal 1, 2, 3. 3 means 2 isomers are present. Now we can write down this ether form in this form also. CCOC. This C represents number of carbon atom, C represents carbon atom, and we have not written down the hydrogen because hydrogen is easily filled here. So we do not need hydrogen atom. So simply write down the carbon. Here number of carbon atom. You have to choose longer group. This is longer group and here 4 carbon atoms are present. So isomers equal 4 number of carbon atom means 4 isomers. So total number of isomers. Total number of isomers of this molecular formula equal 8 plus 2 plus 4 equal 14 isomers. So 14 isomers are present in this molecular formula. So we can find out the number of isomers by this method. So let's calculate of first of all alcohol and ether. We will discuss all the possible questions from this alcohol and ether relating to the calculating number of isomers. So first question, let's calculate of general molecular formula C4H10O. Another example, C4H10O. Now write down in alcoholic form. First of all alcoholic form, then first C4 carbon atom, then OH. Hydrogen will be filled by this way. We do not have to keep hydrogen atom. We only need the number of carbon atom. So number of carbon atom equal 4, and we have to remember that formula, 11,248. 11,248. So number of carbon atom 4. So for 1, 2, 3, 4 number of carbon atom, 4 isomers are present. Isomers equal 4, and write down in the ether form. 1, 2. Now here number of carbon atom. You should not calculate total number of carbon atom. You only have to look the longer chain beside functional group in the left side or right side. Longer chain you should choose. In this structure, longer group is this or this. Both are longer groups, and we have to choose only one, either this or this. We can choose any of this, and here 2 carbon atoms are present. So isomers equal, for 2 carbon atom 1 isomer, and we can write down this ether form in this form also. So here number of carbon atom in the longer chain. So number of carbon atom equal 3. So total isomers equal, for 3 number of carbon atom we have to look this rule, 1 carbon atom, 2 carbon atom, 3 carbon atom. So for 3 carbon atom 2 isomers are present. So total number of isomers for this molecular formula is 4 plus 1 plus 2. 4, 5, 6, 7 isomers are present. So total number of isomer in C4H10O is 7 isomers. So we can calculate it easily without writing structure. So now another question, how many alcohol isomers are possible for C4H10O? In this question, typical alcohol isomer is asked. So you should not have to calculate the isomers in ether form. So this question is very easy. Now you have to write only alcoholic form. So 4 carbon atom, then OH. So number of carbon atom equal 4, and isomers equal 4, because we have to remember this rule 1 1 2 4 8. So for 4 number of carbon atom, 1 2 3 4 number of carbon atom, 4 isomers are present. So total number of isomers, total number of alcoholic isomers equal 4. So you can calculate it very easily. Hope you understand this question. So now let's start another question. How many ether isomers are possible for C4H10O? How many ether isomers are possible for C4H10O? Now, in this question, only ether isomers are asked. So, you should not have to write the alcoholic forms. So, directly write ether forms. For C4H10O, write only ether form. 1, 2, 4 carbon atoms are fulfilled. Here 4 carbons are present. So 1, 2, 3, 4. 4 carbon are fulfilled. So number of carbon atoms. Look only longer chain in ether form. So number of carbon atom equal 2. So isomers equal, you have to remember this formula, 11,248. So for 2 number of carbon atom, 1 isomer is present, and this ether form can be written in this form also, second form also. So number of carbon atom in second ether form equal, look longer chain, here 3 number of carbon atom are present. So number of isomers equal, for 3 1 2 3 number of carbon atom, 2 isomers are present. So total isomer, total ether isomer equal 1 plus 2 equal 3. So 3 is the correct answer for this question. Now last question in alcohol ether form. How many alcohol isomers are possible for C5H11OH, C5H11OH, which are primary in nature. C5H11OH. So you have to write the alcohol form first. C5H11OH. Number of carbon atom equal 5. So total alcohol isomer equal, here you can look this rule, 1 2 3 4 5. So 5 number of carbon atom, 8 isomers are present. So total isomer equal 8. These include all primary, secondary and tertiary form, but in the question only primary isomers, primary alcohol isomers is asked. So this total isomer represents all primary, secondary and tertiary. So we have to calculate only primary isomer. Now you have to write down the structure of the carbon atom if this question is asked. Otherwise you can calculate very easily by this rule. For this question you have to write down the structure. So 8 isomers are present. So first isomer 1 2 3 4 5. This is first isomer, and second isomer you can change the position of functional group 5, and this by changing the functional group 2 isomers are formed. And third 1 2 3 4 5. In this structure in first position, in this structure in second position there is functional group, and in this structure in third position there is functional group. Now 4. Now you can change the substituent. Now you can change the substituent CH3, and this is 4 isomer. Fifth, and now you can change CH3 1 2 3 4 5 carbon atom. Here also 1 2 3 4 5 carbon atom are present. So 5 isomers. We have to know 8 isomers. Now 6 1 2 3 4. Now change position of both substituent and functional group. Change the position of both substituent and functional group. Here OH and here CH3. 6 isomers are present. Then 7 1 2 3 4 CH3 and CH3. 7 isomers. So you can see we have to know only primary alcohol isomers. After the 4 5 number of the carbon atom, secondary and tertiary are present. So in this question we should not know the number of isomers in secondary and tertiary form. So total number of primary isomer equal 4. This 1 primary isomer, second 1, second, third, and this fourth. This is present in the parent chain, so this is also primary isomer. So 4 primary isomers are present, and for the secondary isomer, total number of secondary isomer equal we have total number of isomer 8, primary isomer are 4, and only one tertiary form. Total number of tertiary isomer equal 1. Only one tertiary isomers are present in the any formula. In any formula only one tertiary isomer are present. So you can calculate it by subtracting 8 minus 4 minus 1 equal 3. So total number of secondary isomer equal 3 and total number of tertiary isomer equal 1. So you have to simply learn this rule and you can calculate the ether isomer, alcohol isomer and total isomer of given molecular formula. So it's a very easy technique to calculate in entrance examination. As time is limited in the entrance examination, we have to calculate fast. So thank you guys for looking this video. Hope you like this video. So don't forget to like, comment and subscribe my channel, and I will put more and more videos relating to entrance examination. So thank you very much.